Is week 1 for the Data 16 course about database systems. This is chapter 1. So we will talk about database applications, and we will give some examples of what databases are and what they are used for. So databases are important. They're very widespread. They're popular. You have many applications. So for examples, for sales, retail sales, if we are selling products or services, then we need to store our information, such as who our customers are, the description of our products, how many of those products we have still available in stock, and how many of them were purchased and what are the purchase orders. All of this information can and is being stored in databases. For accounting purposes, we want to store our payments, receipts, assets. All of this information can be stored in database. Human resources information about our employees. Who are the company employees? What are their salaries? How many taxes they're paying, and so on. So for any business or enterprise, this information will be stored. If we look at banks, they have the same situation. Customers, information about the customer, their accounts, what amount of money they have in their accounts, the transactions that they're making, any purchases, any deposits of money, the paychecks that they get will be saved in here. Credit card transactions. From financial point of view, any sales, purchases, financial instruments, stocks and bonds, and so on would be saved in databases. Can any of you give another example of what databases can be used for?
Like online shopping, e-commerce businesses.
Very good. Online shopping. Online retailers like Amazon.com, and many retailers have a website like Walmart, and even grocery stores would have online shopping. So for orders online and for customized recommendations, databases are used. Anyone else?
Professor, from like for example, space research organizations can store data related to the trajectories that their spacecrafts have moved, and other data that they collect from space.
Okay, very good. Spacecrafts.
ERP management systems, Professor, like inventories, sales, purchases.
Yeah, inventory, sales, and purchases. That's what we said over here. It is used for sales.
Healthcare system also uses database to keep records of their patients and other medical bills.
Very good. Medical institutions would use the databases, right? That's very important here. Medical records. So when we go to the doctor, the medical exams that are performed, the medical history of the patients. Then doctors would use sometimes computer systems for diagnosis, for placing diagnosis. So database of diseases and their treatments. Alright. Then we also have the human genome database that talks about human genes. Other important databases are computer networks. Right? So we need the internet to talk to each other. All of the computers in the world and how they are connected together, and which router connects which network to the internet. How about social media? All the Facebook data, Twitter data. These are humongous databases and one of the biggest in the world. How about
streaming services?
Yeah, streaming data.
Spotify, Netflix, anything like that.
These in different colors so that we can easily see them. So the World Wide Web, right? Huge database. All the web pages in the world. Web of linked documents through hyperlinks. Right? World Wide Web is different than the internet. The internet is the network. This is like the physical infrastructure of routers and switches and cables that makes the connections possible. But the World Wide Web is the application of documents that are linked together, and that's a database. Database of web pages that looks like a huge graph of pages and links between them. So Google, is working with this database. Google and search engines. So, as you can see, databases are very important and they're very widespread, and you have many uses. From computers, social networks, web pages, to biological and medical data, to spacecrafts, to manufacturing of cars, for example, different machines, right? Airlines, reservation systems and schedules of flights, universities, students records and grades and degrees, right? So there is quite a bit of practical applications of these databases. So that is why these databases are important, and we will be spending our time in this class to learn about how the databases are created, how they're managed, and how they work. And we will be creating some sample databases with your group today and in the following class activities. So, a database could be something like the web of linked documents, the World Wide Web. A database could be just a text file that contains our customer names, our patient names, or the products that we are producing. We could implement our own database management system by writing some code we could implement our own system if we wanted to. But why do this when the database management systems already exist that are ready to use? And what do we mean by database management system? So we could store our data in a text file if we wanted to. Our customers, products, patients, orders, etc. We could put this text file onto our hard drive, of course. But if we wanted to search through the data, retrieve records, be able to multiple users making updates simultaneously, if we want to be able to do things like this to our file, then we need to write the code to do that. We could totally do this by using some programming language like C, C++, C#, Java, Python, Perl, something else, if we want to. Now, but why do we need to do this? Because the database management systems already exist. We don't really need to do this. Such as, can anybody give an example of a database management system?
Oracle DBMS.
Oracle.
PostgreSQL.
Say it again.
DBWeb.
IBM DB2,
PostgreSQL.
Can you type it in the chat? Because I can't hear very well. Okay, there we go. SQL Lite. What else here? Post PostgreSQL, MongoDB, Elasticsearch. Very good. Many databases have about Microsoft SQL Server. Many databases exist, management systems, right? We don't need to code our own one, but we could if we wanted to. All of these things are database management systems. This means they would allow us to search and send queries. So what is all of this SQL here? SQL, SQLite, PostgreSQL. So the SQL is the structured query language. This is a language that allows us to send queries to the database to retrieve records. For example, give me all customers of age 27 or bigger. Or give me all orders that were placed on October 26th, for example. And then the database management system goes search through the records and send us this information. We could also make updates if we want to add new records, and multiple people can do this at the same time. We can add tables or delete tables or delete the entire database if we want to, or create a new one. So the system allows us to do this. It also maintains backups of the data in case they get lost, and it's able to restore them. And some of those, like this one, Elasticsearch, are able to maintain big data, right? If data is very big and it cannot be stored onto one machine, this database might be able to management system break the data into pieces and store each one on a separate machine to be able to maintain the size of the data. So all of that is handled by the database management system internal logic or code. So it provides us redundancy or backups in the face of failure. So it could make multiple copies of the data. If one of them is lost, it will be able to restore it from another copy. It allows us to access the data. Like we said, we could query data and retrieve records. Depends what the data looks like, alright? Because we gave some examples here. Data can be used for web pages. Web pages are very different than customers or patients, right? Or we could have Netflix wants to recommend a movie to a person to watch. It could be a database of movies. So we could be storing customers, we could be storing web pages, we could be storing human genes, medical exams, we could be storing videos, music, or pictures. How about Facebook and Google? We could be storing web pages. All of these would be unique file formats that are placed into the database. So depending on what we are storing, we would choose the database management system. And then integrity, the database management system will also handle for us, let's say there is a secret data. Okay, this could be a government data or a military data. And somebody needs to be authorized properly to log into these data. So it'll ask for login, username and password, and make sure that only certain authorized employees can access this data. Integrity constraints have to do with the formats of the files as well. So to maintain data integrity, but to maintain constraints as well. So let's say if we want to enter a credit card, it needs to be a 16-digit number, right? If we type blue eyes for credit card, it will say, hey, that's not a credit card. What are you talking about? So integrity needs to be changed, right? The types, what format is this data in? Okay, what we just mentioned earlier, multiple users might be wanting to update the data in the same time. If this is happening, the database management system would handle this by performing atomic transactions. What this means is until one transaction or action is completed, and the record can be locked, and only after it is completed the next update can be applied to it, and it is either completed fully or it is abandoned. So it's either fully done or it never happens. Here you go. Or does not happen at all. So if we are transferring some money from one bank account to another and some failure happened, the network connection was lost, the database crashed, or something like that, then this transaction is completely abandoned. Never performed. And all of the actions and transactions that we are performing are recorded in the system log. So we know what happened. We know we tried to transfer these funds and didn't work because the network failed or something else crashed on us. So this is what's called the atomic action. Either performed completely or not at all, and during that time this particular record is locked, so there couldn't be another user trying to update this particular data at the same time. The first one makes the update, it's finished, and then the record is unlocked for the others to make their updates later. So this is the situation with concurrent access. So the record is locked while user is using it, and then the next one comes. So if two people are reading the balance, if they're reading it, it could be okay because they're just reading it. The problem is if they are withdrawing monies at the same time, that's a problem. If they are writing or updating, if they're just reading, they're gonna be okay. So, if they're making updates, writes, or changes, that's when the problem happens. That we need this concurrency. And like we mentioned, protection of data, the data is secret or private or has, copyrights and things like this. Then we need to provide user access. Specific user has access to whatever data they're allowed to have access to. We are now in this class studying a relational database. This relational database means that it has tables and relations between them. So that's why it's called a relational database. What do we mean they are relations? If there is a customer and he places orders, there is a relation between the customer table and the order table because the customer placed the order. By semantics, we mean what is the data means. Is this retail? Is it financial, medical, and so on? Car manufacturing or what? Constraints. Credit card number is a integer or it's a number. Credit card is a number with 16 digits, alright? We cannot enter blue eyes for credit cards. It has to be a number. Relational model is what we will be studying in this class. Entity relationship is we will be creating a diagram that shows what is the relationship between the entities. The entities could be these customers, patients, things like this. It could be a product that we are producing, car, refrigerator, music player. So it is an object of some sort. That's why it's called object-based, because it can be, and this entity, it can be anything. That's why we call it an object. So this kind of data that has tables, and it's called structured data because it has attributes, which are descriptions, and then it has objects. When we have tables with descriptions and objects, that's called a structured data. Now, there is other kinds that are semi-structured. XML uses tags like HTML, but custom tags, so that we can create a tag called customer or student or patient and then save all the information about this. Customer inside of that tag. Now it could be unstructured, and then that's kind of a problem. Like Facebook, who's got messages and pictures. There are no rows and columns that describe the messages and the pictures. It's just a bunch of pictures. Same situation is with the web pages. Page, links. There is no structure here. In this situation, we can't really save this one in a relational database. So some big data tools are used, like Hadoop, MapReduce, and Spark, to be able to save this kind of data and query them and analyze them. And we have special SQL called NoSQL or SQL that works on these guys here, Hadoop and Spark, to be able to retrieve records from this kind of unstructured data. So let's look at our tables. This is the structured data right here. It has rows and columns. In the rows we have the objects. In the columns we have the attributes. Objects, rows, and tuples are the same thing. They are in the horizontally listed, and then on vertically we have the columns. These are also called attributes, columns, or descriptions of the objects. If the object is a customer, his description could be age, education, address, eye color, hair color, size of shoes, things like this. It's a description of the object, right? If it's an employee name, department that he works in, his employee ID, what is his salary. If it's a student, which classes is he taking, what grades did he make, is he doing a master's degree or a bachelor's degree. So descriptions would be on the columns here. And then we can have multiple tables. One of them is the customer and the other one is the order that he placed. Or one of them is the employee and the other one is the departments in the company. So they can be linked through a common attribute that they have. Let's say employee ID works in this department, or department ID is placed inside the employee table so that we know which department the employee is in. And then the employee and the department table are linked by the department ID, because both tables contain this column. Like right here, both these tables contain the column called department name, so we can link them by department name. And when we do something like that, that's called a primary key or a key. So we will be seeing how we can link those tables like this, and to describe the links, we would use something called an entity relationship diagram. That kind of looks like this, where the entities will be placed in squares or rectangles, and then the relationships between them will be shown. When we are sending queries to the database, we can create something called a view. Let's say we only want to see two tables, or we only want to see the relationship between two tables. We can create view 1, the two tables, view 2, the relationship between the two tables, and we can create many such views. We create those by sending a special SQL command. But there is a physical level where the data is stored physically on a hard drive of the database server machine, and there is a logical level where we logically have the design of the database. We have tables. What is the meaning of the table? Is it a customer? Is it a student? Is it a patient? And how logically they're linked. These two are linked through the department name. So that's called the logical level. And then the views can be created. That's also called a schema. The tables that the database creates, the primary keys or the keys that are used to link those tables, make the logical schema of the database. The physical schema is where it is stored physically on the hard drive of the server machine running the database management system. Okay, so that is all that we will have for this lecture, and we will continue with chapter 2 next time.